Between a recursive and explicit definition. So given the recursive definition, that is an equal with 3, this is the first term. Just let me take one pen. Let me take one pen here. This means is a first term is a1, and this 1/3 is a r, the common ratio. And now we can translate into the explicit definition for the geometric sequences, and the formula for the explicit formula for the geometric sequences is an is equal with a1, a sub 1, times r in exponent n minus 1. So now when we want to translate this, we can write this way: an is equal, instead of a1, we already have here 3, so it's a 3, and instead of the r common ratio, we plug in 1/3 in exponent n minus 1, and then whatever term we have to find, we can find any term we want to find it here. Now let's go here when we have the explicit definition, and what is the recursive definition for the geometric sequences. We already know this 3 signifies the first term, a1, and this number 2 signifies the common ratio r, and we already saw there the recursive definition is equal with this 4. a1 here, what is a1? Is a 3, and when the number of the terms is n is equal with 1. And now here is r time, r is a 2 in this case, time of the previous term of an, because I have here an, here is a sub n minus 1. Whenever n is greater than 1, for a second term, third term, fourth term, etc. That's what does it mean. Now here in this example 4, given the explicit definition, an 6 times 1.2 in exponent n minus 1. What is the recursive definition for the geometric sequence? So 6 is first term, a1, and 1.2 is r. The same way what we did on the previous example. So an is equal, so now we are writing in the recursive definition. So we are translating from explicit definition into the recursive definition. Now the first term here is a 6. When n is equal with, the first term is equal with 1, the first term. It means a1 is equal to 6. And now r is 1.2, because an is equal with r times the previous term. So it means r is 1.2 times a, the previous term of an is an minus 1, an sub minus 1. Whenever n is greater than 1, it means for a second term, for example, a2 is going to be 1.2 times a1, a3 is going to be 1.2 times a2, etc. And we can find whatever term they are asking us, we can find those terms with either definition. If, for example, the question asks us to find the 7 or 8, or to find it with a recursive definition, we are going to find this way. But if they are looking, for example, with the explicit definition, we are using this formula here.